A piecewise function is a function in math that is defined by more than just one singular equation. And the reason that these are so valuable is a lot of times a real world pattern or process might not be defined by just one singular shape or type of mathematical curve. It might be a combination of different shapes. Like for example, as the stock market rises and falls, it's comprised of many different curves. And we might not necessarily want to think about that as, well, could this be represented by a single f of x is equal to whatever, or we could break it into pieces based on, well, for this component, it looks somewhat like a line, whereas here, it looks more like a parabola, and vice versa. Basically, we can break it down into pieces and represent each one of those pieces based on, well, what is the respective domain of those particular pieces. So let's just start off by looking at how we write a piecewise function and what's the proper notation. And then we'll examine how to graph it and stuff like that. But the first one says, let g of x be equal to, and then this is the notation which is fairly common for piecewise function, where we use a brace symbol, like an extended brace symbol, to separate the different mathematical formulas for that function. So in this case, we have g of x is equal to x squared plus 1, or it's equal to 3x minus 4. And well, as we know about functions, one of the problems is you can't have a function be equal to two different things at once, right? Because if we're plugging in, say, 5 in for the independent variable, we want to know, well, what is the outcome? What is g of 5? It can't be equal to two things. That would be a failure of the vertical line test. It would defeat the very nature of a function having to have a single predictable outcome. So how we often write it is, well, the first line of the function x squared plus 1 only is valid if x is less than 2. And again, this is correspondent to the input, not the output. So it has nothing to do with the outcome of this formula, but simply to do with what goes into it. So say, for example, we wanted to know what is g of 0. Since 0 is x, right, in the case of the input of the function, that qualifies for 0 is less than 2. So basically what that means is that we'd be using the first piece of this function for its formula, because we use this if x is less than 2, which it is in that case. And then notice the second piece, 3x minus 4, is valid if x is greater than or equal to 2. In this case, they're completely opposite intervals. And this basically tells us, well, no matter what x is, we're going to either use this one or this one. Sometimes a piecewise function might have the gap in the domain, which is also fine. But basically, the secondary portion of the equation is kind of how you specify what the domain is for each piece. And it's always followed by if. So in the case of g of 0, we're going to be using the first formula because the input x is less than 2. So we're going to be using the formula x squared plus 1. So 0 is going to be plugged in, but it's 0 squared plus 1, which is, of course, 0 plus 1, or 1. So we can see that g of 0 is equal to 1. And g of 1, we'd follow the exact same process, because 1 is less than 2. So we're going to still be using that first formula. And 1 squared plus 1 is 1 plus 1, which is, of course, 2. And we can evaluate it the same as a normal function. No differences, just using the top formula. But at some point, like, for example, say we wanted to do g of 2, we would not want to plug it into that first component because 2 is not less than 2. And it says to use this if x is less than 2. So basically, we want to make sure we don't use that, but we would use the second component instead, because that one says, well, if x is greater than or equal to 2, we're going to be using the formula 3x minus 4 to be equal to what g of x is. So basically, we're going to swap to the second formula for this, because now we're in the portion of our piecewise function where x is greater than or equal to 2. So that would be 3 times x minus 4. And again, we're just going to take 3 times the input minus 4 once we are at that point where we're greater than or equal to 2. And so that would be 6 minus 4, which is also 2. And remember, the output of a function is allowed to have you're allowed to have duplication in the output, but when you're inputting one, it can't go into both. And that's why the elements of the domain cannot be overlapping. Now, if you're wondering, well, what if they are overlapping? What if I'm given such a piecewise function? Well, that already is just garbage to begin with, so you should never deal with that because that already violates the basic condition for a mathematical function. And say we wanted to do g of 3 or g of 4. Again, those would be using the second piece of the function, which would leave us with, well, 3 times 3 minus 4, or 3 times 4 minus 4. So I'm plugging those numbers into that second 3x minus 4 instead. And in this case, that would leave us with 9 minus 4, which is 5. And in the last one, 12 minus 4 would be 8. And so what I get is a different pattern for the second piece and the first piece. And what this creates for the graph of a piecewise function is a combination of two different shapes. Now, those shapes are not the entire graph, and we're going to be reviewing quadratic and linear functions in the next, well, actually in the same exact lecture series. But what you'll notice is, like, we'll look at the graph in another example. It will look like a couple different shapes put together, but they won't be overlapping again, because it'll be sort of like you're cutting part of a curve and pasting it to another part when we look at a graph. And then when we're on the negative side, again, now I would make sure to use the first curve, and just a reminder that when you're going to be plugging it into, since -1 is less than 2, I would switch back to the first curve, and for some reason this one's out of order with respect to the others. But I would need to make sure to use x squared plus 1. Reminder, when you're plugging in a negative into x squared, we need to make sure to square the negative because the entire input is squared. So since -1 is the entire input, I want to square that. And that would still leave me with 1 plus 1, which is 2. And anyways, I can get a lot of repetition in a piecewise function. In the next video, we'll talk more about graphing, and I'll show you how you can sort of create a graph of a piecewise function using a calculator.